If you're watching this on YouTube and aren't subscribed, make sure and click the subscribe button, like, comment, let us know what you think about the episode. Also, make sure you turn on notifications. There's a ton of people that are viewing our podcast that aren't subscribed, so if you want to stay up to date on the latest information going on in diesel, latest news with emissions, parts, anything like that, this is definitely the place to be able to get in-depth content, so make sure you turn on the notifications so you're in the know. Today I'm going to be chatting with Matt from DFC Diesel, and he had some really excellent insights about failures that he sees on engine cores and how that can translate to an engine that's operating just fine, or when we get to the remanufacturing process, things that they look for to ensure that those issues don't continue to happen. So I'm looking forward to chatting with him today. Before we get to it, we want to give a shout out to Kershaw Knives. We appreciate them being a sponsor of the podcast, and they've got a 40% off MSRP code for you. If you use code 40 TDP 2024 at kershaw.kaiusa.com, you get 40% off retail. It's a great way to save some money, get some cool gear. If you're in the market for an EDC knife or something to use around the job site, around the house, they've got you covered with a bunch of different blade steels, blade shapes, different opening mechanisms to choose from, and their whole lineup's designed to meet any budget. So if you're in the market, head to their website and get 40% off retail with 40 TDP 2024. All right, let's get to today's podcast with Matt from DFC Diesel and talking about these failures that he's seeing across the board with different diesel engines. Matt, welcome back to the Diesel Podcast. Look forward to talking engines with you today and learning some more about, really all of them and some really cool things that we have planned to chat about on this episode. So welcome back.
Yeah, thanks for having me. Yeah, it's been a while. It's like, didn't realize so much time had passed since the last one.
We were chatting, before the podcast about a topic that I think is really important for truck owners, especially if, whether it's an older truck, newer truck. I think what you want to talk to us about is going to really apply, and that's the thing of cores, engine cores, different components to it. And so I wanted to ask you what are we missing? What am I missing in my understanding of what it takes to remanufacture an engine and how cores factor into that?
So I think cores are often like an overlooked component of the actual, I guess you could say like the remanufactured puzzle that we work on, just in the sense that we like the core is the foundation of every engine we build. And so, as a remanufacturer versus a manufacturer is from the manufacturer starting with like a new block, a new crank, new castings, the heads, like new parts, everything. And so where it creates a heightened level of complexity for remanufacture is, well, we would have like a standard list of new wearable components that go into every engine, like, pistons, rings, bearings, gaskets, and then things like guides, seats, valves, stuff like that. We are still having to reuse and remanufacture like the cylinder block, the crankshaft, camshaft, cylinder heads. And as more time goes on, I mean, those parts do actually deteriorate, so it's becomes more challenging to remanufacture the older engine gets. So I think a lot of times some people expect that, it's like, oh, it's been 10 years since that engine built, the price should be coming down more, but sometimes the price starts going up as time goes on because there's a lot more core degradation and you're having to buy like more new castings to kind of keep the quality where you're at. And then that's kind of what starts separating different remanufacturing philosophies, because when you get into a lot larger scale of things, you focus more on like lean manufacturing, which is about reusing as many components as possible. But that's usually why you also get a more limited warranty. And then you can have very, very expensive performance builds where they use new everything, but then it becomes like where it's far too expensive for the average person, or like the average person doesn't need that level of complexity in their engine. So the cores are definitely where it's like, I think that's actually the nucleus that kind of holds all the different variables together or whatever, on deciding like what level of quality do we want to build the engines to, and then what type of warranty do we want to back those components up with.
Yeah, because it's the foundation of the whole build, whether it's the block, the heads, other components. So kind of regardless of what kind of new parts you're putting onto it, if there's a flaw or an issue in that foundation,
Mhm.
it's just gonna kind of derail the whole build or not meet expectations or get super expensive, or you have like, a warranty that's not very long or very encompassing. What
Mhm.
are what are some of the things when a core comes in to DFC that you guys look for? I'm sure it varies by Cummins, Duramax, Power Stroke, or maybe it doesn't vary a whole lot, but what do you guys look for? What are red flags that pop up in a core where you're like, we can't use this?
Uh, how long do we have in this? Um,
As much time as you want.
yeah. Um, you know, like there's obviously a lot of universal things that we just apply. I mean, because we always have the common components that we're reusing the most and trying to reclaim. So that's typically like the head casting, the block, the crankshaft, the camshaft, the connecting rods, and then most the rest of the internal components beyond that we're just putting in as a new standard list every time. But um, obviously the depending on the type of engine and then where that casting was produced and then even like the type of material it was made out of plays a big part in like, well, what's going to be the fallout we see. I mean, when you talk about cylinder heads, I mean, the aluminum heads, definitely appear a lot more durable than the cast iron ones because the cast irons, you know, like whenever a cylinder head cracks, it's because it's actually relieving stress. So I mean, you're essentially having it where it's like, well, there's tension amongst everything from expansion contraction, and so it cracks to essentially relieve that tension in those areas. Um, and so what we found interesting because we obviously sell right across North America and then like a few places internationally. It's always interesting to see how even the types of failures you see in cores also depend on the climate. Like for example, extreme cold up here in Canada, we're hitting like -40, -50 can produce different failures than let's say extreme heat in like some of the southern states and stuff, or get into Mexico. So and then obviously then you see on cores when you're even trying to let's say like tear them apart and clean them and stuff, getting cores from let's say the East Coast look a lot different than getting cores from the West Coast, just because of even the humidity in the air and stuff. So when it comes to like the cleaning processes and the engine disassembly and everything else, I mean, while there are kind of universal steps you take, some cores also require far more input than others do. Um, and I know I'm kind of keeping this generalized because sometimes it's kind of going down the rabbit hole for like, well, which engine platform do I pick on first? And then which component, because like it's kind of like all of like internally when we're tearing apart an engine, like I mean it's not our intention, like we're not trying to like saddle the customer with an extra bill. Like we if anything, we want a usable core more than anything, because if we don't have a usable core, we can't build another engine for the next customer. And so to try and keep prices down and keep them in line and affordable for as many people as possible, we have like core assessment forms that ship out with every engine to try and give some transparency on, well, this is what we need to get back as a usable core to provide the next person with. Because we gave you a good component, we gave you a one that we felt that's going to last like lifetime of your vehicle and everything else. So we want to be able to have a component that we figure is going to last for the next person. Um, and like I guess with that being said, it's like how do I want to phrase that? Like I had one of the big three in touring our facility a couple of years ago, and they were trying to sell me on how, because a lot of companies and a lot of customers out there like having what they call like a guaranteed core charge, which means that what you might pay 3,000, 4,000, $5,000 for a core charge, but as long as you return the same components that you were shipped, you're going to get your full core charge back. So they're having a tour around my shop and they're like, you know what, Matt, like it looks like you have a great thing going here. We're not going to try and sell you that our engine's like of superior quality to what you're doing here, but we'd like to sell you on the core charge. So we're walking around and all of a sudden we come across one of the particular cores in question on the floor, and it had a big hole at the side of it. And they're like, well, for example, you could return that to us because we're going to fix that.
Wow.
So it's kind of like, a lot of people when they're buying an engine and they, let's say, go to a place that says they have a guaranteed core charge, I mean, that's where you start getting into like, patching holes, you get into spray welding of the main line of the crankshaft bore. You get spray welding of cylinders. You get a lot more either welding of cylinder heads or a lot more stitch pins and things. You can start getting like a lot more sleeves, and most of them are usually thin wall sleeves versus thick ones. Because that way, when they dip it in liquid nitrogen, it's easier to pretty much like pull it out of liquid nitrogen, just drop it in the hole, and it's going to expand back to create the interference fit. You're going to get where you get crankshaft bearings that have spun, they've turned black. Some of them get ground and re-welded back up. So, and I'm not necessarily knocking any of those processes because there is a time and place for all of them. I mean, it just really depends. Like, I mean, you get into the really, really big engines, for example, where a crankshaft's 20 feet long. Like, I mean, if I was a customer, I'd want them to do whatever they could, try and save that. But then when it's like, let's say, a lesser value, people are like, well, I don't want that repaired. I want to have like a good factory casting. So, um, and it really does come down to be like how competent are the staff or the people that are actually applying some of these repair processes, because that's ultimately what's going to dictate how long that engine lasts and if you're going to have premature failures.
This is a this is a topic that whenever I've talked engines with friends or people that are out there, we tend to focus in on, I don't want to call it the shiny parts because you don't see them when the engine's put together, but we focus in on like billet rods and a camshaft and what
Mm-hmm.
kind of head studs do we have? What do we do with the valve springs and those things? But a conversation about what type of core I'm getting has never popped up. I've never had anybody say to me like, I want to make sure this my core engine, or the parts that are used in it meet this standard. So I think it's really important to talk about this because I bet a lot of listeners, truck owners out there, they're probably not asking that question, or they're wondering, hey, if I order this short block or this long block, were all these steps, was a checklist gone through with all these parts? Is it qualified as a good core?
Mm-hmm. Yeah, and because I think like we briefly talked about is I think sometimes what gets overlooked is everyone just assumes like, like if you had an engine that was built in 2005, for example, think like we're still, remanufacturing that same block that was made in 2005, like it's 19 years old at this point. And so at some point does get to be where it's heat cycled enough times that it'll start developing like, potential cracks. You can have more opportunities for failures in different areas. And then that's where it kind of leads into, like I was saying before, is sooner or later, even though the engine's, excuse me, a lot older, the remanufacturing costs actually continue to increase the older it gets, because then you're having to buy like a new block or a new head or new casting. And then that actually leads into something that, again, like everyone automatically assumes because you buy something new that it's without fault or failure. Well, right now, I mean, if you buy a 20-year-old part from the dealer, it's incredibly expensive. They're usually very inexpensive when they're like, the first couple of years of production, but they get more expensive over time. So for the average, I don't think the average customer is willing to pay like an extra $3,000 to get a brand new, crankshaft from, you know, Chevy or Cummins or something. Um, uh, so then, you can look to the aftermarket a lot, to be honest, like a lot of the aftermarket, I mean, comes out of China and things like that. And I mean, um, because I think a lot of the factory ones are made like more like South America and some of the other places. But when you do start buying some of these aftermarket castings, it does also have it where you have to still treat these new parts like they're cores. Like, I mean, crankshafts, like we just got a batch of 10 cranks from one supplier, and it's like, everything looked good. I mean, you pull them out, everyone would assume, oh, I can just bolt this in an engine. Then we put them in the V blocks, and the thing's already has like a 3 thou uh, uh, like when you spin it in has like a 3,000 deflection or whatever to the middle of the crank by the time you roll it through the V blocks. And then it's like, well, it was likely not ground that way, but then how did they ship them to us? Was it properly like supported and stuff all the way, or did it deflect in the box? But that could prematurely take out bearings and stuff. We sometimes get them where there's still chatter marks in some of the seal surfaces, so you still have to polish them again, or the RA finish is too high and you have to polish them some more. And then even like a lot of the brand new, like sometimes we're buying brand new blocks right from the OE. Um, so I mean, it's not like an aftermarket job or one or anything else, and we're still having to, you know, um, re-hone all the surfaces and the cylinder bores for the correct finish that's going to last longer, and we're having to run a main line on it because maybe the bearing clearance is too tight, or we're having to surface the deck because it's still like too high on the RA finish, and it leads you down the rabbit hole of like, well, I mean, the OE engine was fine or it lasted. It's like, I mean, in many cases, it's not saying that, you know, some of the clearances we see wouldn't necessarily work, but it's like, how long will they work for? I mean, we're ultimately trying to build an engine that outlasts your truck, not just the warranty. And so we want to, you know, if we know we can make it better, like why wouldn't we?
Yeah. Yeah, and I was just thinking of a phrase that I see a lot with automotive, which is meet or exceeds like OE standards. Could be for anything, but we
Mhm.
see that a lot. And then what you just mentioned, when I think about, well, what is that OE standard, and does it vary, and does it
Mhm.
have highs and lows? Because I've seen that kind of rants from shop owners that are getting OE parts directly from whatever company it is, and they're
Mhm.
saying like, 3 of the 10 I got I can't use, and these are brand new from the OEM. So I
Yeah.
imagine that adds a whole other component, and really makes the remanufacturing process even harder or even more challenging.
Well, and that's what leads back to be. I mean, it's a big reason why we pushed to get ISO certified, in the last year or so, is because it also meant that we had to bring in a level of standardization into every process we do so that, it doesn't matter whether it's a brand new part or it's a used part, they all go through the same QC checks. So, I mean, again, it's like sometimes people just think it's like, oh, we'll just go and buy this part. It's going to be faster. It's going to be cheaper. It's like, well, and unfortunately, it doesn't work that way because we end up the even the labor times that go into a lot of these components. We're putting in almost as much time in brand new castings of things as we are in on used ones that are 10 years old.
What can be really, I think, really tough overall with it as well. And I know you can't answer it because there's so many variables with when that engine was made or when that part was cast. What part of the world did it come from? Like you mentioned, heat, cold, that all affects it. Salt spray, like tons of different things. But
Mhm.
with these older trucks, is you just, I guess you really, as a consumer, you just don't know, like, how long is this going to be good for, or if I am shopping around or looking for different engine build options, what am I actually getting?
Mhm.
um, there just seems to be so much variation with it that it, like, as a truck owner, I would be overwhelmed by it. I wouldn't know where to like where to start or what to
Yeah.
do or anything like that.
Well, I mean, and this is why it kind of goes back to be why I've always felt like, DFC still offers some of the best value, overall in the marketplace is because, like, when we're saying like, we're giving a 5 year, 100,000 mile or 160,000 kilometer warranty on something on parts and workmanship. I mean, think like these parts we're reclaiming, we're having to stand behind as well. So think we don't make the block or the crank or the heads or anything, but like we're still saying that's like, well, if a crankshaft breaks or a block cracks a cylinder line or anything else, as long as we're not seeing evidence of someone, let's say, using it for an application it wasn't designed or dramatically exceeding its design limits. Like, I mean, I'm not gonna, you know you're not gonna warranty, let's say, like something that cracks a cylinder liner and you find out that the guy hit it with like 2 stages of nitrous out drag racing on the weekend. um but like, just for example, um but think like, because we're standing behind it, I mean, that's where we're giving more value to the customer. I mean, when you have a more limited warranty of, let's say, like, a year or 2 years, 3 years, whatever it may be, I mean, we're still taking on that existing liability to say that, like, look, like, we're confident in our remanufacturing process. We're confident that, the components that we're giving you are of good quality, and we're willing to stand behind them for longer. So, I mean, I think we briefly touched on it on another podcast, but I mean, it sounds counterintuitive, but whoever has the longest warranty has the most warranties. Because think it's like even if we build an engine exactly the same as someone that has a 1 year warranty, if we warrantied it for 20 years, which one's going to have more warranty?
Right. Yeah, no, that makes sense. I've just never thought about it like this, and I can't believe I missed kind of this topic of asking these questions. And I know that somebody is probably listening and they're thinking, Patrick, ask him when Cummins engines, how old do they have to be before this happens? Or what about this Power Stroke, or what about this Duramax? But I feel like I can't, because you don't know all the variables, or you wouldn't know, all the different things that have happened over 20 years to somebody's particular truck. But are there kind of some trends or some data or things that you've seen either with different types of engines or anything like that, where something's just kind of a major issue with the core, maybe something with the heads, maybe it's like the VP trucks and some of the things in the heads that they would crack because of the heat, or something with blocks or anything like that with any of the big three engines?
Yeah, I mean, and that's, I think, where I kind of stalled out on my thoughts there for a second earlier in the show, or whatever, is just because those are running through my head so fast. But I mean, like for sure, like different type of castings have more inherent flaws. Like, I mean, if you were to talk about, let's say, the 6 liter 6.4 cylinder heads, where the valve goes inside the head and where they cut the seat angle from factory, it's like induction hardened. So I think it's like the entire head's one cast piece. There's no seat, and then they obviously like induction harden that area. It goes about 80, 50, 80 thou deep into the casting. But those are ones where, just as it heat cycles over time, you get little kind of cracks in behind where the valve area is. And the thing is it doesn't really cause any engine failure or anything. I mean, really, you're just going to be bypassing the valve a bit on the combustion gases, and you're going to have more crankcase pressure and things. But I mean, someone pulls one of those things apart and the heads are cracked. It's like, well, the engine probably still ran fine, but now you identified something that's like, well, this doesn't look right, and I want it fixed, or I want a new casting, sort of thing. But then you get into things like we talked about, the Duramax LMLs are probably the most notorious for breaking crankshafts and stuff. And it's, there's lots of variables that go into it, but it's kind of the balance between, well, how much power is it putting out, and and how much weight is it towing, how is it tuned, and everything else. Like, I mean, if people genuinely wanted like the reliability of the old 12 valve and 7.3, take one of these new engines and detune them to 150 horse, and the thing will last forever. Like, they're made out of better materials, and they have more technology in them than they've ever had before. And they are built way better than historically they have been, but we're asking more out of them than we ever have before too. Um, then when you get into things like, I mean, like I said, the aluminum heads seem to be holding up the best out of all of them. But again, it's like there's not a lot of material you can surface off of them before they're getting too thin. And so the highest likelihood of replacing aluminum head is just from expansion contraction over a long period of time. You've like left some grooves in the face of the cylinder head that are now past the point of where you can surface it. But it's not, we do still get some, like, let's say 6.7 Ford and Duramax ones that do develop cracks in the head, and they'll leak coolant sometimes in the cylinders or externally. Then when you get into the 6.7 Cummins, I mean, because you have a lot less material in between the cylinders compared to a 5.9, you get a lot more expansion contraction that ends up, having the head gasket groove into the deck of the block and groove into the cylinder head. So again, sometimes you get it where there's not enough material left to surface the head to reuse it, or same thing on the block, you're taking it below the minimum spec. And again, too, like, I mean, depending on like how someone wants to look at the specs or whatever, I mean, there's different ways to argue them. I mean, obviously there's things like AERA spec and or else the OEM ones, and they're saying, well, this is the maximum piston protrusion, or the the thinnest the head could go. And it's because all of those clearances have to work together. I mean, you know, we have to definitely stay within all of them because again, it's like, we're, ISO certified, but then, we're also assuming that if someone takes their engines apart to criticize them, there's nothing left to criticize. But I mean, obviously there's you still see lots of other manufacturers out there where they could cheat, clearances one way or the other, and it's not going to cause any type of failure in it. Because like if you let's say you're above maximum piston protrusion by a little bit, but you're still a long way to go from your minimum spec and valve recession, you're not going to have piston to valve contact, is one example. And then obviously the aftermarket in the racing industry brings lots of things. Like, I mean, you see guys like offset grinding the crankshaft journals to add some extra stroke to them, or boring cylinders that were never designed to go a lot larger and putting in liners and stuff. So I mean, there's, and those are all perfectly acceptable because that's a racing application, right? Um, but forget what else to add on to that one. But yeah, don't definitely been interesting, whatever. Like I said, just like observing all these different things over the years, and that's where I've said before. It's like we never say it's like, well, we've seen everything at this point, because it's like then it's like, oh, I've never seen that one before.
Common question we get from you guys a lot is, hey, I need a diesel engine. I either, I can't wait this long to get one, or normal place I get stuff from it just takes too long, or they don't have the parts in it that I need. Maybe my truck's not stock, or I tow heavy with it. I don't want to go back with just a stock engine. DFC Diesel is a sponsor of the podcast. We worked with them, hand in hand on doing episodes, answering technical questions. They have a complete lineup of Cummins, Duramax, and Power Stroke remanufactured engines that are set to a standard of ISO 9001 2015 standards, which is a huge deal in the aftermarket. And there's certain levels of quality testing, validation that are required for that. So when you get one of those engines, the type of quality that's built behind it, with an industry-leading warranty that's really comprehensive. And the other thing with that is, sometimes the options that are out there, it's a basic OEM engine. You want a little bit more. You don't want to have the same failure again. So there's a bunch of different series of engines that they have, from core, street, tow haul, and also the Speed of Air series, which we've covered on the podcast before. There's a lot of really cool benefits to it. And if you have questions about that, reach out to them. If you don't know the type of engine that you're looking for, if you go to dfcdiesel.com, there's a ton of info there. You can send an email or you can reach out to them. Also, they're working with Speed of Air pistons, which it's the only piston that pays for itself. And there's a lot of really cool technology behind it. So you can add that into your build and be able to get better fuel economy, increase power, increase torque, and better engine life out of it. Some of the most common engine applications or series of engines that they have with that lead time, a lot of them are in stock or they have really short lead times. So you can check your favorite retailer or go to dfcdiesel.com, check them out, see what's in stock, see what you can get. If you have questions, maybe you want to do something that's outside of the normal series of engines, they have tons of choices for rods, cranks, pistons, valve train upgrades, tons of different things. So if you're in the market, definitely make sure and head on over and check them out. Well, there's so much data that you have. And I think you'd mentioned that the castings and some of the things that are done on newer trucks are better than the older ones. And I guess it could kind of be tougher. Maybe you need another like 5 to 10 years and more time to go on some of these newer blocks or newer head castings and things like that. But is there any data that you have for newer trucks and some of the different material and the way that they're casting things that you're finding like there's a definitive longevity difference between, say, like a 2017 6.7 Power Stroke and what a 7.3 might have been for the cores, as we're talking about that part, or with Cummins or with Duramax? Is there a big jump in newer technology and those holding up better versus the older ones, or is it just kind of 50-50, kind of washes out? They're all about the same.
Well, again, like talk about the variables that change. So I mean, on some of the newer blocks, like the Ford and the Cummins ones, they come out with the new CGI, like compacted graphite iron blocks, which again, they're a lot stronger, they're a lot lighter. I mean, that it helps increase even the GVW, the truck, keeping the weight down, but still being able to handle power. But as much as like the materials have improved, it doesn't necessarily mean that engine's going to be able to be remanufactured easier over time. And part of that reason is a lot of these engines are kind of getting built where, they'll last for their intended purpose. You'll get good life out of them, if left generally stock and stuff and not turned up too much. But when the time comes to remanufacture it, most of it's a throwaway. And they are making the engines that way where, again, and they can do it a lot of different ways. Like, starting to do things like where there's there's very little material left to surface off the block, or there's very little material to take off the heads, or, I know none of the diesels we work on have it, but if you get into like some of the Mercedes ones and where you have like overhead cams that are gear drive, like, well, you can't surface the head or block, because then you're going to run into meshing issues with the gear drive. And then, little things like, having it where like the gear presses on a crankshaft. So, I mean, if it slips, I mean, excuse me, I'm not saying that it couldn't be repaired, but, it makes it a lot more challenging that, it's like, well, is this gear still lined up from where it was factory? Because there's no keyway to locate it. Um, and then, and then other things too, where it's like, okay, well then if there's a chronic bearing issue in it, then it ends up wiping out the main line in the block or something. Or, if they're known for spinning cam bushings, I mean, there are ways of repairing it, but the problem is that all of these repairs ultimately take more time, cost more money, which ultimately pushes up the cost of the remanufactured engine. And so then you're put in a position where sometimes you're still competing with the OE, because if they maintain the production run long enough, they're able to offer kind of a brand new casting engine for a lot longer than you can reman one for. Which is why we have to look at like, ways to differentiate ourselves, such as like, well, there are still obviously like common failure points in every engine that we can improve upon. We can offer obviously like the upgrades like the speed of air pistons or something in them, or even, where you go to like ARP, or other aftermarket head studs, different things throughout the engine, and then plus also our warranty. And that's kind of how we differentiate ourselves of, if they are still offering them at a really cheap price from factory, we can differentiate our engines from offering these other things instead.
So the newer technology, while it does have benefits to, really the truck owner, whether it's what it's rated to tow or payload or the weight of the vehicle or how quiet it is, it's also really providing some challenges for a remanufacturer because of what you mentioned with how some things are almost a throwaway, or what they're designed to do. There's not a lot of give. There's not a lot of stuff that you can do to make them serviceable longer. So that might be something in the future that, as it plays out, might be even
Mhm.
tougher on some of these newer trucks.
Well, and that's the thing, is I think we're pretty much almost there actually, because there's always a bit of a lag time from when a truck first comes out to when you first start seeing the engine selling steady. And so even a lot of the existing engines out built in the last like 5 years, like we're not really like we haven't really got into remanufacturing many of them at all yet. Um, and that's where we're already seeing like a lot more of the challenges and stuff. Like, for example, like you get into something like the newer Ford engines, like they all come with a steel piston. I mean, I could be wrong, but I mean, I haven't seen any evidence to have it where any of the aftermarket piston manufacturers are going to make an oversized steel piston. So then your next thing is like, okay, well, if it gets reman, are we going to switch to an aluminum piston, which should still be fine or whatever. I mean, some people are going to push back and not want that. They're like, it came with a steel one, I want a steel one. But then your only alternative is like, well, then I either need a new block every time with new standard pistons, or I need to sleeve every cylinder. But then the sleeves you're putting in may or may not be as good a quality as this factory cylinder bores were in the CGI block. So it's like, it's kind of like the damned if you do, damned if you don't type situation.
This got a lot more. I don't want to. It's not confusing, but there's a lot more questions that I would ask as a truck owner if I needed a short block or long block that I never would have thought to ask as it pertains to cores and what I'm getting. And I think there's like so many different directions like the conversation can go between new, old, what's serviceable, what isn't. And then like you mentioned, I imagine a lot of truck owners like and I've seen it with 6.7 Power Stroke owners. Like they like the steel pistons, they want the steel pistons.
Mhm.
Well, if there's nothing available with an oversized piston, then what am I going to do? There's going to be a lot more choices or questions that
Yeah.
they're going to have to face when they're looking at an engine build.
Yeah, and that's where too, where it's just like that's the unfortunate reality is like if you want a certain set of variables, then I mean, as humans, it's like anything's possible, but I mean it's just gonna cost more money.
Yeah,
And then that's too is like, we're still like, you still want to make it feasible where it's just, where the customer is going to want to fix their truck and repair it. Because I mean, if it gets too expensive, then it's just like, you know what? It's not financially worth it. I'll just go get a new truck and this one will go to the scrapyard or something.
yeah,
Luckily speaking, the last 10 or 15 years have taught us the vehicles are worth so much now that, I still figure your average newer truck's going to have a couple of engines and, 10 transmissions and a whole bunch of diffs and everything else put into it just because a new one's so expensive now.
yeah. Yeah, that makes a lot of sense. I've seen it a lot with the transmission side of what I remember, like an aftermarket one costing 7, 8, 9, 10 years ago. Versus now, it starts to reach that point where I would think, do I want to invest this kind of money into it, or do I want to, get something new, or what what fits my budget? So I can see that being a huge part of the remanufacturing process is providing that pricing value where I would want to do it as a truck owner
Like
versus just getting something else.
one example to give is I'll pick on the 6.4 engine because I mean it's probably never ending podcast about that one, however. But I think it was background, we being up in Canada, we started building them a lot sooner than I think the US market had demand for them. So we started getting big into building them around 2013 or so. And for a while we were doing like, 30, 40 of the things a month, back when even DFC was a lot smaller back then too. And um all of a sudden out of the blue, I think it was like in 1 month where we had like 3 or 4 engines all of a sudden, built them all, shipped them out the door, and they all came back where they're full of coolant and they wiped out the main line. They took out the turbos, like needed oil coolers, everything. And what we found was there's on those blocks, there's 3 center bolts on either side, like the head bolts on either side of the bank closest to the valley. The 3 center ones, the casting can actually crack where the coarse end of the thread is on the head bolt, and then it'll actually leak coolant right up the stud or the head bolt, and then just fill the crankcase. So within 500-600 miles or whatever, you have so much coolant in the oil that it just wipes out the bearings. So back in 2015, we got to where, well, every long block we build, we actually pressure test for like 20 minutes afterwards. Um, after we bolted the heads on, and I'd still say about 1 in 100 engines we do, we end up, oh, it's cracked, it's losing pressure, and we got to take it all apart and throw the block out. Because I haven't found any what I would consider to be a proper fix that I would be confident standing behind for 5 years, 100,000 miles to repair those threads. And and we've had good success. I mean, I think of since we've done that, I think we've only ever maybe had 1 or 2 that cracked, let's say 20,000 miles after we built the engine. But again, too, it's like we warranted it and everything else. However, I mean, it wasn't our fault. It wasn't our technician's fault or anyone that assembled it. It's just here's a case where the core itself, like the block from factory, just reached its breaking point and it finally had a failure and took it out. But this is why you want a reputable company that stands behind a warranty on it.
Is there anything as a like what a customer or truck owner when they're pricing an engine or they jump on your website or they call you guys, they're going to see the price of the engine, they're going to match it up, or you guys are going to help them match it up to whatever they're doing with the truck, and they see that core charge, and it's going to be conditioned on it being a good usable core. Are
Mhm.
there any things that they should look out for so that they can be prepared to know, maybe not know with 100% certainty, but they can go into it and say, hey, I know I'm probably not going to get my full core back, like, and not including like a rod through the block or something like
Yeah.
that, but just like, are there things that they can do or questions they should ask to have the best chance to get, the core refund, or just know up front, hey, I'm going to lose some of the money because this happened with it. This was a failure point. What kind of things should they think about when they're wondering, is my core usable?
Well, so again, this kind of comes back to, so the onus on this one is kind of more on the shop or whoever's actually doing the work on the vehicle, because this is ultimately why it's really important to that you have to properly diagnose like what was the root cause of failure of the engine in the first place. And that's not just to capture it on the core chart, it's also to make sure that you repair it correctly. Like, I mean, if you had, let's say, fuel contamination and the injectors went, which ultimately melted a piston, you wouldn't want to just bolt in a long block and not replace the injectors or fix the fuel system. Or we've seen it too, where if you dropped a valve seat, um, like we actually have, like I think I talked about before, but we have these stickers we put all over our engine that they're like a low adhesive sticker that are kind of like a reminder for the technician to check certain things, because we've had Cummins, this has happened numerous times, previous to the stickers and even once or twice afterwards, where I believe the sticker says something like clean and inspect turbo, turbo and manifold before installing or whatever. And the reason why is like we've had it where, let's say, on a Cummins, a seat dropped and then it hammered the top of the piston and it broke off chunks of the valve and chunks of the seat or whatever. And they actually made it into the exhaust housing of the turbo. But some people, when they swap it, they just pull the whole manifold and turbo off the engine and then they bolt it back on. Well, then they start the engine up and that debris makes it back into the cylinder of the new engine and goes through it again.
Oh, that would be horrible. If I was
Yeah.
a customer, that wouldn't be fun.
No, and like these things do happen, which is why we're trying to, have as much transparency or education as possible. Um, but those would be a case where it's like, like when someone's returning a core or whatever else, like, if they had, let's say there was damage in a cylinder, you'd want to look in, let's say you could look in with a camera, when you pull the injector out of it. And if there's obvious cylinder damage, I mean, there's a good chance that you're going to get a deduction for the cylinder heads no good, because you know, um, people don't want to have it where, the visually speaking, an entire cylinder is like, beat up really bad or whatever. And they wouldn't want that in a new engine. So it's like, well, we have to go and find a new casting for that. And again, too, there's also the time too where, I mean, you could say that's like, well, just charge the extra money and just include everyone at the new casting. But I mean, again, we don't deduct for a lot of cores. I mean, relative to the amount of engines we build. We try and associate with a specific like individual or customer. Like in my opinion, this is kind of an extreme example, but let's say someone's driving down the road and they start hearing it where the engine's making noise and it's starting to blow smoke out, and they have the mentality, it's like drive it till it quits, drive it till it produces a part number out the back of the truck sort of thing. um, like in my opinion, I don't believe that customer should have it where, if they drove it to destruction and they're causing excess damage to that engine, I mean, they should have to pay more or whatever to repair that than a customer who, again, they did hear something. Let's say they got a rod knock and its engine started knocking, they pulled over, shut the engine off right away. Like just because it spun a bearing, we don't necessarily deduct saying the crank's no good. What we'll do is we'll tear apart the engine, we take photos of everything, and if we can still, let's say, grind the crankshaft journal to an oversize and it's maintained like a proper surface finish, it hasn't, let's say, discolored it where it's turned black or anything, and we're comfortable again sending it to the next customer, like, we're not doing a core deduction on that because we can still reclaim the part. Where we're deducting is like, well, obviously if the crank broke, you're getting a deduction on that. We can't use it for the next customer. Or if they drove it to the point that it turned black and removed all the heat treating in it, we can't use that again. And it's not just about we can't use it again, but it's like it's trying to make the customer understand, like, just like you're buying a premium quality engine and you're expecting premium quality parts in it, and to maintain that amongst all customers is like what we gave you was, again, like great quality, so we have to be able to give the next person that as well. But I do know that core deductions is kind of a touchy subject with a lot of people that don't understand why they're getting them. But we're still ultimately trying to keep the cost of these remanufactured units down as low as we can, to again help provide value to the most amount of people.
I think like a podcast like this really helps for somebody to be able to understand how the core factors into it, because when they get that engine from you guys, they're going to want to know that they got the best quality engine, short block, long block, they got the best parts they could, and
Mhm.
they're going to be up and running. Well, so does the next guy. He wants the same thing as well. So um, I think it's something that would be. I guess it depends like what the engine failure is, but just if I had something that happened, is can I shut off the vehicle? Can I not drive it? Can I get it towed? Can I do whatever it is to try to prevent more damage from happening,
Yeah.
or more more things that might fail inside the engine?
Well, and some things that customers would never see is that like we've actually had this happen a couple times in the last few months where we had a deduction on like let's say like a mainline issue on a block or whatever, and the customer says, well, fine, I want the block back because my machine shop will use that. And it's like, okay, I don't doubt that your machine shop will use it because probably about 80% of the cores that we reject and we say, we're not comfortable using this and being able to stand behind it for 5 years plus. I'd probably say about 80% of other manufacturers are happy to use. And we sell a lot of our cores that we're rejecting back to other manufacturers. Um, and again, I'm not saying that like what they're using is wrong or bad, but I mean it does come down to be that liability aspect where we have to be confident that what we're providing is good for 5 years, 100 plus thousand miles. The shop that's gonna say, oh, we'd still use that. It's like, well, they offer a 6 month warranty. It's not an apples to apples comparison.
That's a really good point. I had a conversation not too long ago where somebody was looking for an engine that I know. He's got an 0559, and he had found some place. I think it was a 90-day warranty or something on this
Mhm.
engine, and I'm like, you need to ask other questions. And really, I know it's sitting there. It's the price you want to pay. You can get it quick, but it's such a big investment. And he used it for work,
Mhm.
as well. But I see that happen a lot. It's just like sometimes somebody will find something, it's below the price they want to pay, and it's like this 90-day warranty or this 6 month warranty or something like that. And it's just, you really got to ask the questions. And I think about, understanding the core situation and understanding not just, well, really not just even cores, but the engine I'm getting back.
Yeah.
Somebody went through it, somebody checked off all the things that they're looking for. So I feel more confident in it versus an engine that's been sitting in the corner for 17 years and somebody can just put it together for me real quick. It makes me hesitate.
Yeah.
If that was my engine and I needed one.
Well, I mean, and if you're to visualize like a seesaw, for example, I mean, on one side of it, you have it where, cheapest price possible, but on the other side of it, you have accountability. Um, the thing is like how do you get the proper balance between the two of them?
Yeah.
And when I say accountability, it means that like, well, if someone has a 90-day warranty and they have a cheap price, really that their motivation behind it is like, I don't I don't want to have any accountability or liability with this thing. Um, I think that what I did is fine, and as long as it can make it 90 days, it's not my problem. On the other side of it is like someone wants to save money, and and again, like I get it, like money's tight with lots of people, and um, and it can be, I don't know, just everything in this world is so much more expensive than it was or whatever. So I mean, I get it. Like, we're trying to I think what the biggest pursuit is, even if people don't realize, is we're ultimately after like, well, what's the best value I'm going to get? Like, I still think
Yeah.
vast majority, obviously, of people that buy DFC engines are like, well, I mean, we might be a little bit more expensive, we might be a bit cheaper than other manufacturers, but overall, it's like we're saying it's like we're doing the best we possibly can to offer you the best quality product for the longest period of time we can. Um, again, like I know lots of other companies that, build incredibly good quality engines and they offer a very limited warranty. Um, but that's kind of where it touches into like they're building a great quality engine, but there might be like $5,000 or $10,000 more for their engine than ours is because they are choosing to manufacture it where it does come with an even more standard list of new parts, and it might include like new head castings or new crankshaft or new whatever else. Um, which again, like it's it's a great package and everything else, but unfortunately, not everyone can afford that either.
Yeah.
So it still always steers back to be of like, how do we have this? How do we have this? The best balance we can get between getting the most value, which includes like having the best warranty and coverage you possibly can at the most affordable price possible, sort of thing.
There's a lot of really good info in today's podcast that we haven't covered. I haven't thought of really a lot of it, even outside of just the engine, like transmission cores and other cores and things like that. But it's a lot of really good information that we should ask as consumers and understand what we're buying, what we're getting in return, and then being able to, I think, get that value that you mentioned, which is so incredibly important now, is getting the best we can for the money we have to spend it. So I appreciate you bringing up this topic and then going into detail with us and being able to help people make informed decisions. Because like I said, I've never heard it anywhere else. I've never seen a whole lot of videos on it or really read anything. So it's a fantastic topic.
Yeah. No, yeah, it's just like I said, it's a constantly challenge. It's probably one of the most challenging issues we actually face here all the time. Whatever is just like it's not just about finding people to tear them apart, but then like what steps do we have to take to qualify them to make sure they're good and 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 again, like as they get older, it actually just gets more challenging. So yeah, that's why when I was thinking of like what do we talk about next, this would be a great one to cover. I'm sure I could probably go for another 4 or 5 hours on it, but I mean that'd be a little bit might be getting a little redundant at that point.
Well, it was great to hear these insights. I appreciate you chatting with me today and going over them. I always love talking with you, and I love the educational aspect and the technical information and just being able to understand more, because I don't see it. It's not out there front and center a lot in this industry. So there's a lot of great insights, and I appreciate your time chatting with me today, Matt.
Yeah, no, thanks for having me.
Don't forget, Diesel fans, make sure and head on over to Kershaw.kaiusa.com. Use code 40 TDP 2024 for 40% off retail. If you're in the market for an EDC knife or something for hunting, fishing, around the job site, around the house, they've got you covered with a complete lineup of different choices you can pick from. Different blade steels, blade shape, different opening mechanisms, and their whole lineup is designed to meet really any budget that you might have. So we appreciate them offering that discount code just for Diesel Podcast listeners. Also want to give a shout out to some of our Patreon supporters: Tyler Loewen of 23 Diesel, CUTTERUP Rob, J Cole, all of our other Patreon supporters, all of you who subscribe on YouTube podcast apps, follow us on social media. We appreciate all your support here in year 8 of the Diesel Podcast and look forward to bringing you more of the content that you want to hear in 2024. Till next time, keep the shiny side up.